Okie dokie. Good morning, good afternoon, good evening, wherever you are in the world, and happy Valentine's Day. Welcome, everyone. It's great to have you join us today. I'm Jenny DiFigueredo, the Community Manager here for DVC. I'm extremely excited about the presentation and discussion we have planned for you today. As you may or may not know, my background has little to do with technology. I came to the world of data science and AI because I was concerned about how data is being used and cared for. This is one of the reasons I work here at Iterative. I have a short anecdote to tee us up here today before we start. My all-time favorite piece of music is Bach's Prelude in G major of his cello suite. I recently learned that Bach brilliantly designed this piece of music to carry us through this very cathartic journey. The piece starts out in G major and feels so delicious and reassuring. That note on the cello just sounds sublime. And so after a few measures of that, he removes the G and he starts moving into using the D, which is a note that is kind of opposite G, and it creates this like tension in the music. And so he continues this way. The pace of the music gets higher and faster, and this angst is developing inside the music. And it's like going in different directions, attempting to get back to this like peaceful place that it started at. So eventually it finally does, because the G major is reinserted into the music and the tension is released and everything arrives back in peace at the end of the music. So thinking of this music reminded me of what has happened, especially in the last year in AI. We have this, everything was going along and we were doing our data responsibly and finding ways to do that. And then all this new technology came and it's super exciting and we're racing to learn more about it and create more things with it. But there's this like angst building, like, are we doing everything that we're supposed to do? Something's missing here. We need to plug it back in to this system. So our guest today can show us how to put that G major that we're missing right now back into our beautiful AI music that we're making. So Charles Vardeman joins us from the University of Notre Dame, where he is a computational scientist in the Center for Research Computing and a research assistant professor of computer science and engineering. So with that, I will turn it over to Charles, and he will get us started and tell us of all the great things on building trustworthy AI.
Well, thank you. Thank you for this opportunity and speaking to everyone about a subject matter that I think is really important and has become, critically important in the last 2 years, particularly the last year with the explosion of generative AI. So this work that I'm talking about comes from two different projects that were part of this Trusted AI project. And Trusted AI, just as a little bit of background, is a collaboration between the United States Navy. So it's funded through a defense appropriation to start to build relationships for Trusted AI within the United States Navy. So this is Crane Naval Research Surface Warfare Center in Crane, Indiana. They have relationships with both Notre Dame, IU, and Purdue in state. And it started with essentially a conversation of, we're bringing in all these systems into the Navy. Our job is to determine whether or not these systems can be deployed to the fleet. How do we do this, right? And then how do we safeguard these systems once they're deployed to know that they're, not going to be a threat, that they're not, going to have all kinds of issues. And so the conversation was, well, how do we start? Where do we start? And can we, sort of bring in, top field AI researchers to start to attack the problem? From that, at Notre Dame, there are two different projects there's many projects, but two projects that I'm directly involved with. The first one is the Trusted AI cyber frameworks that I'm going to tell you about. And this project is myself as PI, Professor Paul Brenner as a co-PI. And then we have two professional research programmers that are part of this project, James Sweet and Priscilla Moriara. And our illustrious fearless leader, Dr. Chris Sweet, who is the lead PI at Notre Dame for all of the Trusted AI projects. And then we have a very close collaboration with Dr. Gene Camp or Professor Camp at Indiana University. And we have a technical point of contact, a TPOC, Dr. Adam Schull, that is sort of guiding us along. Now, that's sort of the boilerplate, and I'll talk a lot about boilerplate, I think, in this talk, but the real work is being done by students, right? And so we have some student alumni up here at the top. We have a former PI that stepped away, Dr. Yart Nabrinsky, who's the head of our center, and then the students at the bottom. The second project, which I'm not going to talk that much about other than 2 slides, is also looking at knowledge engineering. So how do we bring knowledge engineering, old school sort of expert systems AI into the modern age of generative AI? How do we start to structure our data? How do we build things like ontologies and knowledge graphs and all these things that are really popular now with RAG? You'll notice that there's a workforce difference here. So we have a ton of students that have come through this particular project as alumni up here at the top. Professor Paul Brenner is the lead PI, but once again, the rest of the team is here. We have 2 TPOCs. And this is Eli Phillips and Amy Flynn, and I definitely want to call them out. And then down here at the bottom is our current list of students. These are all Notre Dame or Purdue undergraduate students. This is an undergraduate research project almost exclusively. These students are TC students. They're from a variety of backgrounds. They're going off into the real world and applying these things. Not all of them are computer scientists or data scientists. They have different backgrounds, and we actually train them in using some of the fast AI coursework and some other things to get them up to speed so that they can very quickly start to think about the data science parts of the project. So part of this is, how do we do workforce development? How do we get students up to speed very quickly that have diverse backgrounds, not just computer science? And how then we teach them to, apply trusted AI in a consistent way? What kind of frameworks are there? Okay, 2 slides on the knowledge engineering project. So the first one is talking about the U.S. data strategy and big picture that probably a lot of people don't know about. And the second one is from the National Science Foundation, their sort of vision of what data science should look like in scientific research in the future. And they call these open knowledge networks. So how do we connect data through knowledge graphs to have these sort of attributes of secure, visible, accessible, understandable, linked, trustworthy, interoperable, etc. Right? And what sort of guidelines do we need around that? Okay. And so the sort of starter project that we gave the students was from the United States Navy. They have maintenance data sets, as you can imagine, lots of maintenance data sets through the fleet. And they ask interesting questions of the data sets because they want to do predictive maintenance. They want to do smart, sorts of things to the fleet. They want to know what are particularly vulnerable systems for trusted, sort of hardware sort of attributes. And so the idea was that we try to build knowledge graphs from this, but building a knowledge graph is sort of an intensive process. You need to know a lot of background in knowledge engineering. You need to know what an ontology is, how to build an ontology, formal logic, all these sorts of things. And then at the bottom here, you sort of need some machine learning, right? So we want to automate and lower these things, the sort of entry level. And so the question is, can we use AI to sort of start to lower the entry level to making this all work, right? And that, in a nutshell, is what the project was doing, is essentially building something called a knowledge graph over these maintenance data sets to answer questions, right, that the Navy wanted to ask. And we call those competency questions, right? Okay, so that was what the Trusted AI project, the frameworks project, was using as sort of one of the use cases for developing the frameworks, right? There were many others, but this is one where the students in the frameworks project work very closely with the students in the knowledge engineering project to essentially take the experiments they were doing and add in parts of the frameworks to make them more trusted, right? Okay, background on me real quick. So in my introduction, I'm a computational scientist in the Center for Research Computing. My background is actually in theoretical chemistry. And as a graduate student, I built a set of software with my advisor, Dan Gazelter, who's a professor at Notre Dame, called OpenMD. And so the issue is in the early 2000s, there wasn't a lot of software out there that was open source. There was free software to do molecular simulations, but there wasn't something that I can actually look at the code, understand what it's doing, and basically do trusted calculations, right? So we decided that we were going to write our own software in addition to doing science using that software, right? And so we're a bunch of chemists basically trying to build trusted software using version control systems, using refactoring of code, using modular code, how to structure the underlying code, using unit tests, right? So tests are like really important when you're developing research software, because you need to be able to do regression tests to see if there's a change that you make in one area may impact the ability to do simulations in other areas. And so we had a bunch of test systems, Argonne, through the system. And so these, and we had a metadata language. We actually published a paper on constructing a molecular science metadata so that people can look at that metadata and understand exactly what the system is that's being simulated and how it's being simulated. Up until that point, everyone used Fortran cards. And if everyone's looked at a Fortran card, that's a problem. My career built off that, right? So all the rest of the stuff that you read on this thing is built off of how do we build trusted science? How do we start to build communities around trusted science? And so I made this little cartoon. So Dr. Christina Davis is our visualization scientist. She's wonderful. There's a bunch of graphics in here that she's done. And so this was sort of stay there in 2012. And the idea was that, okay, you're a researcher, and being a faculty member doing science is hard. And your students are collecting data, and that data is supposed to end up in a governance place, in a place where, is probably not all that great, but at least it's somewhere, which is your student lab, computer in the group room. But the data is actually on this proprietary system, and that proprietary system is locked into the hardware, the data acquisition card to your spectrometer or whatever the instrument is. And of course, the student is off at presenting her wonderful work at a conference. And I've been to that conference. If there's a conference there, you should go. Okay, so the vision of the future was, hey, wouldn't it be great if we had sort of, machine assistants that could help us make this a little bit easier, right? And so you can ask your assistant, where's the data? And it would know exactly where the data is, but it would know the context around the data. It would know that there's a publication, that would know all about the student that did it. It would know the underlying science that's in the data sets. It would know about licenses that may be attached to the data, right? So you get the data plus related information. And once again, the student is still presenting her wonderful work at a conference. Keep this in mind, because the last slide that I present will tie back to this, okay? All right. What is trust, given the fact that I just mentioned agents, right? So let's ask our current residing king of agents, GPT-4. And it turns out trust is hard, right? So trust is a complex concept that plays a role in relationships and society, right? But I think that the bottom part of this is not bad, right? So expectations of conduct, right? So I know what the thing is going to do. Willingness to essentially allow that thing to do something for me, right? Vulnerability, to understand the risks that are involved, and then its reliability and dependability. And I think those are some pretty good, characteristics. But are they all the characteristics, right? So AI just gave me a definition of trust, but can I actually trust the AI's definition of trust, right? Without some provenance. Where did it get this information from, right? Are there authorities out there that tell me about trust? It didn't give me any of those things in sort of that response, right? And so it's sort of this turtles all the way down in some sense, that you have to have some framework that then allows you to build trust around the AI, right? And so the fundamental question that we were asking with the Navy is, what does that framework look like, both software and conceptually, right? And the Navy is really, this is very important, right? And so there are these sort of common posts that the Navy wants to build autonomous fighter jets. It needs to trust AI. It's deploying these autonomous systems. And as I mentioned, this is, sort of critical. But at the same time, we know that industry is also, struggling with this, right? That, this is the Gardner from 2021, way before the GPTs hit, right? That only 53% of projects made it from a prototype to production, and that these things are hard to scale, right? And so how do we start to lower those costs for making, things scale into production where they're returning value? right? 2022, it's not better, 54%, right? So still a problem. All right. So a moment about trusted AI in the big picture. So trusted AI, as I mentioned in the introduction, is sort of a consortium between IU, Crane, IUPUI, Notre Dame, and Purdue Scale, which is workforce development. And there's 30 some odd, between 20 and 30 some odd projects, I believe, that are part of the system that are currently being funded. And we decided that the frameworks group would sort of concentrate on reducing this huge thing of trustworthy AI to something that had some dimensions to it. And we would start with the dimensions, and this isn't complete, but explainability, safety, robustness, fairness, privacy, sustainability, accountability. Now, the problem is that each of those dimensions of trust actually can have impact at each of the data, the stages of a ML pipeline, right? So if I'm building an ML pipeline, data engineers out there know that this is sort of how we go through data collection, et cetera. But the dimensions of trust, if we have a framework, have to be able to take into account that each of that wheel sort of turns, right, along those dimensions. And then the outer part, we actually have the trustworthy deployment part, right? That these things are developed, they're used, they're analyzed, and they're redesigned. And so the trustworthiness also sort of has to sort of flow along that outer chain, which is returning value to the stakeholder. Okay, so where to start? So there was a talk given in last October. It's been recorded by Paco Nathan, and he has the slides online with a open license. And he has two really good slides that sort of summarize what we were trying to get at. But this was way before our project started, way before he gave this talk. But I think it's still a really good summary. And I would encourage everyone to go look at that talk. It's quite good. And so there, as I mentioned in our talk in the previous slide deck, right, that there's risks, right? So there's risks, and that's one of the attributes of trustworthiness, is to understand and reduce the risks, right? And those risks can be in different sort of dimensions. So one is in research, right? And so you have this sort of wonderful thing where you say you have these AI, the AI hype. So you see something on X that is, hey, look at my wonderful AI system. It's taking over the world. It's 5 lines of code, and it will do everything for you, and singularity because of AGI, right? But from a research perspective, right, our goal is essentially the orange block, right? Our paper's been peer reviewed. It's been accepted at a major conference. The code is somewhere, it's up to you to go from there. But to be useful to the Navy, right, in our discussions, that we need to be in this 3%. We need to be in this green block, right? Our code installs, it runs as expected, it replicates the published results. And there's this really nice paper on computational reproducibility in the biological or biophysics sort of realm, looking at notebooks from Jupyter notebooks from GitHub. And everyone should look at this as to sort of get a scope of the reproducibility problem. And so this is one of the problems is how do we actually create frameworks that allow researchers to create trusted products that accelerate the ability to take something that's a research product and make it usable by end constituents that are in the Navy, right? And where do we start with that? It's a hard problem, right? At the other end, we have sort of where the Navy is, right? And so this is sort of looking at okay, we've got people out there who are, LOL, what's data engineering, but then different degrees of sophistication, right? That, AI, ChatGPT is going to solve all our problems. We'll just let it go. We'll just buy some stuff, right? And then down to the really, savvy enterprise folks that understand that where data fits in, we prepare and train our data sets. We have good labeling, we have good provenance information, and this is now revenue generating, right? And so the goal really is to bring those gaps together. And I maintain that the gap is where trusted AI can help bridge, right? That we increase, address ethical concerns, carbon footprint, security risks, complicated, compliance issues, all of these things trusted AI and a framework for trusted AI can help with, right? All right, where to start? This is somewhat overwhelming, right? And so what we did in the first year is we sort of created a taxonomy. And then we actually physically went and looked at all of these tools, right? It's a lot of tools there, right? And so, and we sort of broke this down in terms of the ML pipeline, because not everything is used at each stage of that pipeline that I sort of mentioned as part of our wheel. And also we tried to bin these into a rough taxonomy of are these platform, are these dev tools, the ML tools. Some of these things, VS Code and RStudio sort of cross those lines. So this is sort of a hard thing. And then you'll notice that we appended to Christina's wonderful diagram this AI copilots and the LLMs, which sort of exploded in the last year. And so now we actually even have, in terms of frameworks, this complication that AI is now with copilots driving these underlying frameworks at every level, right? And so AI is integrated with AI, and so understanding what's going on there is even harder, right? And to complicate things, all of those dimensions of trustworthiness that I sort of outlined that we started with, and they're not exhaustive, but they're just what we sort of determined as a good starting point, can affect any one of these sort of tools, right? So they sort of go through vertically through the dimensions, right? And so we need to understand, how each of these sort of attributes affect each of these sorts of parts of the framework components through their lifetime. Right. And so this is what we call TAI engineering, in context, to understand the context of the tools and catalog those. Right. And I'll show everyone in a second how we sort of approach that. Right. So to get a handle on this, we talked to our Navy friends, and they said, one of the things that we're doing, and the Navy has made a big deal of this, is we're doing software engineering using essentially agile methodology. Right. And so this is GitOps, continuous integration, continuous development. And we decided this may be a good place to start, right? They understand that, they know how to assess this, right? So before you can deploy any software into the fleet, you basically have to go through a bunch of hoops, right? And more of those hoops are dependent upon these, sort of using, GitOps, using containerization and platforms and these sorts of things to understand the security and all of the concerns that are underneath it, right? So we decided to use that as a starting point and say, okay, what do we need for DevOps for AI? What do we need for data ops? And what do we need to model ops? If we can integrate those within the sort of existing set of platforms, what would that look like? And so we started with GitOps as sort of that foundational thing. The Navy uses GitLab. So they have their own sort of deployments of GitLab for version control tracking and GitOps issue tracking, all those sorts of things. We used GitHub because we're researchers and don't necessarily have access to those sort of platforms, but we wanted to use something that was open and really good. And so the first thing we did is we created the ND Crane GitHub organization. And this is where, all of the different kinds of projects, whether they're computer vision or they're knowledge engineering or they're actually trust tools that plug into other frameworks, all that stuff goes in, and our frameworks examples all go into this one sort of location, right? We help people, right? So part of this was to take students, get them to understand the frameworks, and then to help other students and other, folks within the Trusted AI group to move those projects into the GitHub repo, right? And so the idea is that they're teaching in addition to learning the underlying frameworks, right? And in the process, we're bootstrapping the adoption of the underlying sort of sets of technology, right? And so this was one of the goals of the project, right? Testing is super important. I probably don't have to beat that drum too hard here, but this is one of the things that we wanted to make sure is that people understood that when they build software, they should build test cases, even if they're very simple test cases, just to understand. And even if they're syntactic, right, that I made a typo error in my file, it should lint, right? Very simple sorts of things. And this is an example for knowledge engineering of these whole ontology things of how you can sort of integrate those workflows so you know. I mentioned that the DoD is adopting these technologies. And so how AI ready are these? And so we had a group of students who went out and looked at platform one, looked at there's an Army platform and a another Navy platform. This is an Air Force platform. And looked at Iron Bank. So these are hardened containers that go through security checks for deployment for Department of Defense services. So if I want to integrate an AI service, right, something that requires GPUs, something that requires big memory, how AI ready are they, right? And so this is one of the projects that the students went out and looked at. And the answer is sort of ready. I think this is one of the challenges is how to evolve these sort of platforms so that they're more AI ready, and how do we integrate things. The biggest problem, this is the biggest problem that we have, is creating trusted computational environments. And this is not just for AI. In chemistry and in science, we also have this problem. This is a huge problem. And so how do you essentially provision an environment with a software stack that has requirements, right, that may or may not work because something upstream is broken, right? So if you build software, you're dependent upon other software for that software that you're building, and you make choices along the way to lower your development costs or speed up your development, right? And so we sort of settled on a tiered approach, right? And so we think that on the horizon, right, there's maybe some good solutions with dev containers and code spaces, but those have issues, right? Especially if you're on a Mac and you're trying to do something that's hardware accelerated. We think that PDM or poetry, that these PyProject TOMLs are a really good starting point. So that's where the students started out, along with Conda environments, right? So how do we teach them to make sure that they have a Conda environment, how to test that environment? We should deploy these as tests within our GitOps environment, and make sure that they work. And then for actual mission critical deployment, we've sort of looked at these NICS flights. Which are hard, and they're hard for students to understand, but they also are declarative and sort of transparent. Okay, this is a slide to illustrate this with DVC. And so, and this is hot off the presses from this week, right? So there is a new hot, sort of framework for doing prompt engineering, and particularly optimizations of prompts, called DSP. Sort of named after NumPy, that comes out of Stanford NLP group. It's the new hotness, right? And so one of the things I'm interested in terms of the knowledge engineering is, how do we start to optimize the prompt engineering as part of knowledge engineering? I wanted to go in and install this. Now I have a template that I sort of start with that installs all of what I call good framework tools, and DVC is one of those, right? But when I went to install this on Monday, I ended up with a problem, right? And so it uninstalled the version of FSpec, right, that was installed by DVC. That breaks DVC, right? So it basically downgraded it to a previous version. And actually, if you try to run, DVC, it actually fails from the command line. Now, this isn't a huge problem because I have a sandbox version of DVC that the command line executes. But if I want to include DVC as a library within my code, that now is a little bit of a problem, right? And the culprit is actually Hugging Face datasets. So if anyone from DVC, I'm sure you're listening, the culprit is upstream, right? So it's an upstream dependency. It has nothing to do with you guys, right? But it's the fact that FSpec is used by multiple upstream, sort of projects. And so Hugging Face datasets now, because it hasn't upgraded to the newest version of FSpec, and FSpec created a breaking change, there's now a dependency problem, which causes all kinds of issues that you may not have noticed unless you were actually, sort of paying attention to the whole system. So this is an example of what I'm talking about when I look at, a super fun site of computational environments, right? One other thing that we've looked at is something called software bill of materials. And so a software bill of materials is trying to address this problem by creating a declarative knowledge graph of software dependencies, right? And if you do business with the government, this is becoming essentially a requirement that you have to submit an SBOM in some accepted format that basically looks through all of your dependency trees and sort of catalogs those along with other information, right? There's a good standard that we like called SPDX, which comes from the Linux Foundation. And our close colleague at IU, she's part of Trusted AI, Professor Jean Camp, she's on the standards committee for building this. And so last summer, we decided to go through and look at the tools. So there's a tool from Microsoft, which is integrated into GitHub that automatically can produce these. There's a couple of other open source tools out there. And we decided to look at these from the knowledge graph perspective. Like if I expand these things out, they're built as knowledge graphs. JSON LD can be essentially transformed into a graph structure. What kind of coverage, right? So is all the metadata populated? Is none of the metadata populated? All these sorts of things. I don't really have time to sort of go into it, but I put the link here. This was built in the framework. And so as the students were using notebooks to sort of, and KG Lab to investigate these things, they generated reports along the line, right, as they were going, right? And those get updated to GitHub, right? And so it's not something where, oh, at the end of the day, we have to write a report. It's now integrated into the workflow. So we're lowering that energy. We're lowering that effort that's required to essentially communicate what's going on in your system. And so we think this is one of the other critical components of the framework that I'll talk about in a second. And the tool that we use for that is something called Quarto and NBDev. And NBDev is written by the wonderful folks at Fast AI. One of the problems that we have is that our faculty and students use Jupyter notebooks, but they need to then produce Python code at the end of the day that then is in a Python package that then other people can use. Well, how do we lower that barrier and produce documentation from the experiments at the exact same time? And this is exactly what NBDev is aimed at, right? Is basically creating a notebook-centric development environment that automatically streamlines production of test code, streamlines production of Python code, along with the documentation, which is contained within the notebook, right? And that then can be published to GitHub pages. I encourage people to look at this. I think it's quite good, although it does have some rough edges, right? Okay, I have hit everyone with a fire hose. Are there questions up to this point?
Okay, I have some questions as we wait for if anybody else has any coming through. But first of all, thank you about the F-spec thing. I have already put a note in our internal Slack. Watch minute 28 of today's meetup. So we're on it, whatever we can do there. So as we talked at the tech rehearsal, and this is something that's like on mine. Like, I love this framework. This is so amazing. There's so much meat here, so much great things to chew on and work and put into practice to make things good and right. But my question is like, how is always from like the people perspective, like how do we actually practically make this operate? Like if you take that whole framework that you have there and you overlay all those things, or you turn the dial, like who's in the dial compared to who's doing the code writing? Like, are they the same people? How do you develop teams that are taking care of all of these things and the overlay of these things? Like, is there a way? And, you mentioned automation. Great. Yeah, let's automate as much as we can. That's awesome. But like certain things, probably that's not an option with. So like, how do you think about, or have you even like gone into like how do you develop a team and like what that looks like and what roles and responsibilities are within a team to cover the practicality of the people operating this?
Yeah. So, I mean, I can give you some hints, at least just from our experience, right? So the first thing is to create good documentation, try to lower those barriers with tools, right? And a set of best practices that, okay, you're starting a new project, that new project comes from a template that installs at least some subset of these tools. Doesn't mean that you know how to use these tools in a good way, but at least, it gives you an idea. We found that taking a student who's sort of majored on this, right, or a professional programmer that has majored on this for a couple months, right, they have a decent understanding, and pairing them with a novice, right, that I'm a grad student, I got this wonderful paper accepted with this code. How do I take it to the next level and make it trusted, right? And sit down with them and sort of walk them through it and do some little bootstrapping with them. And then once you've sort of gotten them to a certain point, it starts to click, right? It's like, oh,
Right.
and then more importantly, see value for yourself, right? So this is sort of like a love letter in some ways to your future self, right? And that's one of the reasons that I do it, right? Is that I may work on some set of data analysis or some code or some ontology or build some knowledge graph or whatever it is I'm doing. And then I'm going to move off, right? And then inevitably somebody is going to go, hey, that's a really great thing. Can you do this, this, and this to it? I'm like, okay, well, I'll go see, if I can, or there's a bug. I've tried to start to use your thing. And going back and trying to figure out what you've done after, 6 months or a year is hard. Going back after many years is hard. And so I think some of these data science, practices are also, if you take put yourself in the other person's shoes sort of thing, or even how this sort of affects your own life. If you take that perspective, then it gives you a little bit more motivation to sort of start to think through these things. Like, oh, I actually take an extra 5 minutes and do this, or if I create some quick documentation. And by the way, I think this is like automation is coming, and if you played with Copilot and some of these other tools that are out there, giving it can generate documentation pretty well, right? And documentation is actually part of the process. And so I think this also does lower barriers. The problem is that Copilot is not a good AI engineer, and it's not a good necessarily software engineer. And I think that's what's missing from these tools is sort of that training in, oh yeah, here's Clippy behind you going, is this in a GitHub repo? Is this have DVC for your data? Where's your data coming from? Is there metadata? All these sorts of things. And it should be able to handle a large percentage of this. It's going to know, these tools are going to know about you and be able to automate the production of some of this stuff. So hopefully that perspective.
Yes, no, that's helpful, but lots to think about. We do have a question from Merritt, one of our wonderful community members. He asked, which LLM models are you leveraging in the pipeline? There was a model for safe and responsibility from Meta, Purple Llama.
Yeah, so this is a big problem. First of all, we sort of take the approach that Andre Karpathy sort of outlined at the OpenAI conference last year of setting baselines via the big brain models, even though I don't trust them. So typically what we'll do is look at what GPT-4 gives us back, but we'll sort of squint at it and say, this is not something that we're going to be able to use necessarily with Navy and secure data. The type of models that we are looking at, so we started playing with a couple of weeks ago, Ollama for local model deployment. That's lowering the barrier to getting some of these models, particularly these smaller fine-tuned models for particular tasks in the pipeline. I think that Hugging Face, and I'm going to talk in a second about data set cards, model cards, why all these things are very important for transparency. If you look at Purple Llama and some of these other sorts of things, some have very good model cards. So I know the fine-tuning data sets that went into it. I can look at the sort of risks that, in terms of biases or other sorts of things. I can pipe that through other sorts of tools. Some of them are just a model card of, yeah, this is how you use the thing and how, I developed it, and go talk to somebody else, right? And I think this is a problem that Hugging Face knows about and are trying to push. But yeah, I think that these smaller, safe and responsible models are like critical. And it's one of the things we started looking at, in the last 6 months or so. Particularly with the Navy and national security and everything else that goes with these things.
Cool. All right, we don't have any more questions from the community. I think we're good to go on now. I have a few more questions, but I'll hold them.
All right. So now on to why DVC. So DVC has graciously invited me to talk about these things a little bit. One of the biggest things for us is that it is a GitOps centered tool, right? Which I sort of mentioned at the beginning. And so it fits with this GitOps ecosystem. It stores its information within Git, but it allows you to connect to remote services, particularly things that are remote file systems for file system based repositories. At Notre Dame, we have shared, something called Andrew File System, AFS, which is ancient, but very dependable. And it's a shared file system and that has very strong permissions, uses Kerberos, but it's very secure, but it's hard to track information and create shared spaces and use that then for machine learning. And so we found that it was fairly straightforward to create, sort of these shared repositories. The information is stored in Git, so we can do a Git pull to a local HPC machine, and then use the information, within DVC to go and grab from the file system the information that we need. The Navy is in the same boat, right? In that they can't always use these open services. They, S3 is sort of available, but it depends upon the project. And so being able to, do this sort of Git-centered environment is important. Likewise, this integrating with Jupyter Lab and VS Code as your dashboard environment is also critical, because they can't always send, telemetry information, other sorts of information to outside services. And so being able to have the information stored within the Git environment, have a really nice tool for exploring that information in VS Code. By the way, kudos to that. It lets us, really, compartmentalize that. And most importantly, it manages the students' experiments. Once we teach them how to set up an experiment in the system, right? And so as a faculty member, and I get this from a lot of the faculty members as to why they want their students to use this, is that you can now, through the visualizations, understand exactly what the student was doing, right? And a lot of times it's not quite what you expected, right? And so this is sort of helping that communication issue and that trust issue of, okay, this is what the model is being trained for. These are the sort of outputs from the training of the model. These are the outputs from the model. All these sorts of things, and it sort of provides that within a structured set of metadata, right? And so the obligatory, sort of screenshots of what this looks like, not very informative, but this is how we use it, right? Is we use it within, Visual Studio Code. We use it for displaying, sort of training. So this is a generative, just quick context. This is generating a synthetic data set for a knowledge graph. And this lets us see how the AI is doing in terms of loss and all these other sort of predictive indicators, right? And understanding that within the environment. We think that integrations are really important. As I mentioned earlier, we have a lot of students that are coming in from a lot of different backgrounds. We used Fast AI. We think that's a fantastic, sort of starting point for students who may not have a deep background in AI or machine learning to quickly, sort of bootstrap their knowledge. We think that, because they're then now using essentially a tabular learner or a vision learner or one of these sort of abstractions within the system, but if you haven't looked at Fast AI, look at it. It's quite good in terms of how they thought through in a very careful way the abstractions that underneath. It's PyTorch. You can still do whatever you want to, you would want to do as an advanced user with PyTorch, but it allows a, sort of a novice user get up to speed very quickly with some guardrails. DVC, integrates with Fast AI in terms of the callbacks, so it makes it fairly easy to also capture that information along the way, and we think that's a really good thing. Hot off the presses, right, is this feature that you guys integrated last year in terms of Hugging Face. So I've mentioned Hugging Face a couple times. We think that the ecosystem for metadata, for model provenance and data set provenance that Hugging Face is starting to build out is crucially important. We think that Hugging Face Hub is likely to be one of those places, just like GitHub, that people go to find data and models. And we think that the fact that you guys now, can track this within a DVC within the repository, what models and data were sort of, included in a set of experiments is crucially important. And we can follow our noses to the underlying system, right? Okay. Metadata standards, right? So I mentioned model cards and data set cards. I would encourage people to go have a quick look at those. Those are markdown files. But there's a set of emerging standards, right? And so one of these is something called Croissant, and Kaggle has adopted this in the last year or so. And so if you go to Kaggle and you want to download a data set, right, you can download a data set, but if you click on it, it says export metadata as croissant. Well, what's a croissant? I mean, I love croissants, especially in Paris with a graduate student, looking at the Eiffel Tower at conferences. But this is essentially a metadata standard, right, that is built amongst the community. And that metadata standard is based off of something that's near and dear to my heart called linked data. And so a quick elevator pitch for what that is. These are built off of web standards plus industry standards, mainly from Google and schema.org. It basically structures the underlying information using a vocabulary, but that vocabulary is dereferenceable, right? And so when I create a @type SC data set, that's actually a web address, that's a URL that I can go and ask that thing for more information, right? And so for structuring metadata, this is really important to be able to follow your nose. As it turns out, for large language models, it's pretty important, right? And so they have this emerging standard that has been adopted by Kaggle. It's being adopted by, it's built into TensorFlow now. It's being built into these higher level frameworks that basically keep track of these underlying sets of information. Now, remember back to that slide, the second cartoon I presented, that wouldn't it be great if I had an agent that I could ask, where's my data? And it would tell me where my data is, but also tell me all kinds of information around my data. Well, I'm going to maintain that we have the starts of something akin to that, right? And so if you go to ML Commons, which is the organization that all these groups are sort of part of, and you look at this data set, I picked it at random, metadata.json, and you paste that into the context window for ChatGPT, and just say, interpret the following JSON. You get back all kinds of information, right? That it's using a combination of schema.org and a custom vocabulary, that thing that I mentioned. It tells you about the metadata. So it tells you the name of the data set, the standard that it adheres to, a description, the license. So this is that legal information, all this other stuff. But it also tells me, about the distribution, right? Tells me that things like data biases or side as, right? And all these other sort of important bits of information. It tells me the underlying structure of the information that I'm going to use for training, right? And so now we have something that's understandable by agents. So ChatGPT, Gemini, all of these models, because they've been trained on tons of web crawled information. Schema.org is used by Google to understand websites. It understands schema.org vocabulary very well as a starting point, right? And so I think that these sorts of efforts are critical, right? And if you look at who's developing Croissant, right? You have Hugging Face, you have Google, you have Dan Brickley, who is part of schema.org. He is a Google employee, but basically maintains schema.org. You have Natasha Noy, who is Google Knowledge Graph. But you also have, these other sort of practitioners, particularly at Meta and Kaggle and these other sort of open source community efforts. And I maintain that community is critical to making progress in trusted AI. Notre Dame just was invited to be a founding member and a partner with some of these organizations, particularly Hugging Face and these other sort of entities in terms of the AI Alliance. So this is Meta and IBM driven effort, but has some universities that are part of it. We're one of the universities that was asked to join, but it's largely commercially driven, right? So you'll notice that most of the green things on here are industry, right? And also, ML Commons and the Linux Foundation are there. So the Linux Foundation, as I said earlier, SPDX, right? And AI parts of SPDX. ML Commons, right? ML Commons is developing Croissant, right? And so I think that these conversations are critically important. Okay, last slide, and then we'll have questions after this. So if you're interested in sort of learning the history of the Trusted AI project, there was sort of two publications. I wrote a quick, KD nuggets with my co-PIs, Dr. Chris Sweet and Dr. Paul Brenner. And then there's a longer sort of post, very long, that I wrote last September, which is sort of a reflection on the sort of, as we were going into our third year of the project, sort of where we came from, the sorts of things that we looked at in terms of governance, in terms of tools, and how those all sort of fit into the trusted AI ecosystem. And with that, I'll take questions.
Great. Thank you so much. This is amazing. I have a couple questions. So Tons of information here. I love the croissant thing. That's really cool. I learned about this from you. Thank you for teaching us all about that. And I love the SBOMs, this software bill of materials, and the SBDX model. Like, it's wonderful to start developing all these standards. Like, that's part of what DBC has always been trying to do, is build standards for creating reproducible data science. And so it's great to see all this come to action. One question that I have is like, okay, we have all this, the framework looks awesome, we need to put this into place. Like, what are the next steps, next best steps for teams to get started implementing this?
Yeah, so I would look at our GitHub repositories I put in the beginning of this. We have some student-built walkthroughs using I think one of them, it uses a PyTorch tutorial. One of them uses, I think, some tutorials from Kaggle. There are some pretty great tutorials out there that DVC has put forward in terms of each of the tools that's part of it. So part of this effort was, we don't want to reinvent the wheel. I mean, we could have gone out and said, okay, these are the things we need to do. Let's just start from scratch. The part of this was, what can we leverage? And part of the evaluation of what we can leverage is how good that tool was at community building, right? Does it have a sustainable community? Is this a project that one person is doing in their spare time, or is there a sustainable community around it, right? And DVC sort of checks that box, as do some of these other sorts of things, right? Do they have good documentation and tutorials, right? I would look, at this is, kind of hard, because I already sort of received one question about generative AI and these llama based, so the sort of open open weight models, not necessarily open data models, which is problematic. But that's an elevator, right? There's a new framework or tool coming out like every couple of weeks. Part of it is, when you adopt something into your ecosystem, to think a little bit about it more than, oh, this solves my immediate problem, and think a little bit about the consequences, right? So this is back to the sort of software engineering. If you're a data engineer and you don't know about GitOps and know how GitHub, so we have sort of a curriculum. The curriculum, starts with the wonderful GitHub tutorials of, this is GitHub, this is issues, this is how you create a test, this is how you can create a dev container. All the students go through the boot camp, right, of that particular thing, right? So it starts with sort of building software, understanding tests, thinking through tests. Usually when we're doing data science, we're thinking of the questions we want to ask of the data. Not necessarily the underlying sort of frameworks that we're using to maybe answer those questions. And so as part of wrapping your head around those couple of extra things that you need to do that. And I think we need communities of practice. I think that, DVC in these sorts of sort of outreach events, I think that there's, this AI engineers group that had a symposium last year in San Francisco. I think that there's a bunch of these organizations. I think that we sometimes get centered on the solving the general AI problem too quickly, and need to take a step back and say, okay, well, there's humans still in the loop. We need to sort of think through how we're building out these tools. We need to do software engineering, the AI engineering, and then LLM engineering, and so sort of layer stack these things, right? And leverage tools, right? So if you find a tool that sort of meets that data requirement, start to leverage them.
Cool. We do have one that came up. I'm not sure if it's a question or a statement, but in this Trustworthy AI, all these standards mentioned here in this presentation are aligned with NIST, ALTAI, and other standards organizations in different groups, different regions. So do you want to speak to that and like how you...
Yeah, so NIST, and actually NIST just, Notre Dame just joined actually this particular working group with NIST. In terms of setting actual standards, right? And so some of the things I sort of talked about were web standards. So these are things set by the W3C, World Wide Web Consortium, same guys that make sure that your web browser works. on different or HTML site loads on different web browsers. I think that NIST putting out these guidelines. So SBOMs are there's a set of guidelines from NIST on SBOMs. I think that a set of sort of these things will come out at some point in time in terms of other documents that give best practices, particularly the sort of evaluation. So one of the things that we're missing right now are evals, right? In terms of how trustworthy you are with respect to different dimensions. We have some students that are thinking about that are sort of working on that, but that's, you ask about upcoming work. That's sort of early days to think about, how do I, have something critique the underlying, GitHub repository for trustworthiness, both to software and to data and to AI, right? And maybe apply tools automatically through tests. I think it's hard. I mean, I don't want to sugarcoat this at all. I think that, these things are challenging just for, if you've ever written software, right? It's hard. Data science adds a layer of complication on top of that. I think DVC lowers some of the issues that are associated with that. And then when you add AI in terms of doing, prompt engineering, doing evals of underlying, behavior of a system, that becomes enormously complicated. With respect to the trustworthiness dimensions, right? Is this thing going to start cursing at my customer when I create this chat thing? Is it going to completely hallucinate, the underlying material that it's presenting back? Is it going to use the wrong tools? Is it going to be able to find the information if it's, presented in a context window for RAG? So I think NIST is a really good start. I think it's, sort of early starting days, of these things, but I think that it's a really good sign, right? And by the way, this has been a bipartisan thing. Senator Young and Senator Braun from Indiana, wanted to make, Indiana is sort of a site for this, so they've been champions of this. But on the Democrat side, President Biden and his Office of Science and Technology Policy have been leading a charge in agreement with, how to start to think about these things. And they charged NIST for this particular trustworthy group, right?
Cool. So I have one more question, and thinking about what you said, teaching in addition to learning and creating AI readiness in the students and kind of onboarding the students and using the teaching learning methodology to get them faster to their things, to being successful. How can you talk to what is the turning point? Do you see, this is something that always happens with us with DVC. There's somebody that from a team that champions DVC, and then they get there and some of them are like, no, we don't want to do this. And so then it takes that time period till the aha moment goes on for them. And so what have you discovered a catalyst for what that moment is when the aha, the light bulb goes off and they're like, oh, now we understand, we need to do that. What makes that change?
Yeah. So I think it's solving your own problems, right? So I think there's different people, are different learners in different ways. Some are visual learners. Some people are conceptual learners. We have to have a conceptual framework, these sorts of things. But independent of that, I think that, one of the things I've observed, and I don't have hard data on this, maybe someday we should try to get at that, is that if you can solve a problem that you've been working on using the tool, or use the tool with a problem that you're trying to solve, then it starts to click, right? Mm-hmm. And so for us, a lot of this has been, I'm training my neural net, and this is my loss data is here, and my other data is here, and I've got some documentation in a Google Doc somewhere, and it's just a thing. And we'll have a student sit down with them and say, okay, well, let's the experiments you're doing, let's actually create the file that will automate some of these experiments, right? Let's make sure that the experiments get put in the experiment data, the outputs, all these sorts of things. This is how you, in some boilerplate code, just include this with the thing you're trying to build, your research notebooks. And you'll get some benefit from this. And usually that's the point when it starts to click up, oh, okay, now I can show my advisor what I'm currently, working on. I can show them the problem I'm running into. The advisor can look at the underlying experiment, the metadata, understand exactly what the experiment is, and understand what the output of these things are. Which data set are you using, right? So this is the other, sort of thing that we run into, is that we have sort of cleaned and derived data sets. So people in data science know this all the time, that you take some data set, it's a giant mess. You go through and you clean it. You remove personal identifier information. You remove strings that make it so it won't parse. You sanity check data formats, all these sorts of things, right? And so, knowing that, which derived data set you're using, right, is important, right, in a set of experiments. So one of the use cases that it sort of clicked for our students was, if I use DVC, I know that it was, John's version of the data set that I'm using as versus Dr. Vardeman's version of the data set, and there's small differences between them, right? Mm-hmm. And so we can use that to track the provenance information upstream, as versus spending 3 hours comparing data sets, which data set is it from? I don't know. I grabbed it from Google Drive. Well, which Drive, so I don't have a general answer, but I think that a lot of people, you have to sort of play with it, right? Yep. And you need really good examples to play with it, right? So that's the other thing. I'm sort of one of those tinkerer learners, right? Mm-hmm. And so I need, a set of examples. How does this work? Why is this important? A diverse sort of set. So I think that having, those sorts of things is important. And we need that across the spectrum for trusted AI, right? It's not just the data part of it, but it's also the model part of it. It's the safety part of it. It's all of these things, right?
Absolutely. We have one last question. I know we're a little over time. Do you have a little?
I have time. I talk a lot. So.
Okay, we have one more question. How can DVC help the reproducibility issues of scientific computing and HPC systems? Could you give me your views?
Yeah, so I mean, this is from limited experience in terms of, like I sort of said earlier, that we have various shared file systems, a sort of fast file system, and then sort of an archival file system that's attached to HPC. And this is traditional sort of science HPC. Cloud HPC is a different sort of critter, but I think that it equally applies in terms of how we might bring data into a compute platform using S3 or some other sort of thing, and using cloud technologies. And we're currently exploring that. So one of the new file systems, the fast file system we're using, is called VAST. That lets us expose certain parts of the file system as an S3 bucket. So I think some of this is dated a little bit. But we found that creating shared, sort of group drives, where each of the HPC users has permissions, and then creating sort of that group repository, and then using Git as sort of that source control. So if you start an experiment, so right now, and we've had users run into this problem of, we have this fast scratch file system, but it's not persistent. If it goes down, you may lose your data. We tell users all the time this, you may lose code. And so one of the things we try to teach the users is that, well, you should use Git as your source of truth, right? If you make a change to the code, that should be in Git. Your workflow on HPC should pull from Git as the primary thing, right? You do a Git checkout in your HPC script. It pulls the underlying code. You run a quick build on that, right? If it fails, then you've got an issue, right? But you do a quick build on the code. And then, or if it's Python, you don't even necessarily have to do that, right? And then use, sort of DVC to pull in the data sources that you need for that particular experiment in the scratch, right? And so now you're basically pulling from a shared drive your own copy of the underlying information that's going to be used in the experiment. Or you can pull from S3, or you can pull from, even Google Drive, right? We've had students who basically put, derived data sets in Google Drive and then just use sort of that, although that's problematic with authentication. If you have an interactive session, you can sort of do that. But, so that's one of the ways that we use it in HPC. I don't know if that sort of answers completely the question, but
hopefully. So, well, with that, since we're over time, I think I'll go to the closing, but I want to thank you so much for being here today. It was great learning all this amazing content that you gave us to chew on and on how to build trustworthy AI. Thank you to the community for all your questions. We always want them. Please find us in Discord and keep asking questions and be a part of the story and what everyone is building and building responsible, trustworthy AI. We will be having our next meetup on February 28th. It will showcase a use case with our new tool, DVCX. And then finally, as you go out in the world today, build some trustworthy AI. Use these frameworks. That's what we encourage. So have a great time, and we'll see you next time.